Hey everybody, we are going to be working with finding the length of a line without using a ruler. And that's going to happen sometimes, right? You're going to have a situation where you're working on a question on a test or out of the book or something like that, and there's no scale to it. So you're not going to be able to use a ruler to find the length of that line. You're going to have to use some other methods. So what are some things we can do? Well, if we had a grid, let's just say that there was a grid included in the question, and if that line was right along the grid, like this one here, oh, come on, it's off. All right, well, you know me, I'm not great at these things, so let's try this again. Okay, so let's say it's right along that grid, and then you can count these, and let's say we got 1, 2, 3, there's 4. Okay, so the length of this line is 4. But for what? Unless somebody told us what the dimensions are for each one of these squares, we might still be out of luck. So if somebody said these are square inches, well, then we know this line is 4 inches long. If they said it's square centimeters, then we know this is 4 centimeters long. And that would work whether it's in a horizontal position or if it was in a vertical position like this one. And we know that's 2 centimeters long, and that's fine too. So that gives us some information, and that's great, but what about these weird situations when the line is at an angle like this one here? Well, some of you are going to say, oh, that's easy. It's still 3. Well, it's not, unfortunately. Anytime you go from this position here up to here, you're lengthening the line slightly. It's a little bit longer than 3. This particular line here is a little bit longer than 3. And how much longer? Well, we're going to need to either use a ruler. If we had one to use, then we could use a ruler for this. Otherwise, we have to rely on another method. And what might that method be? Well, you guessed it. We used it last night when we were doing square roots. We're going to use the square root. So that's going to be our method of working with lines that are of some unknown length, and we don't have a grid that will really help us much with that information. So let's take out our piece of paper, title it Finding the Length of a Line Without Using a Ruler. Put your name, your date, the 3-column system we have here. We're going to use that same system we used from last night, so it's going to be very similar to what you've seen before. And we're going to be taking notes in the center column. Any of the written notes will go in the center column. And then any math work we'll do over here on the very far right-hand corner. All right, so let's start with over here. We're going to be working with trying to find this line that we don't know the length of. So if we have a line, here's our line right here, and we are trying to figure out the length of that line. Unfortunately, it's not like we can magically figure out how long this line is. We do need some more information, and so without more information, we really can't go any further. If this is all I gave you, yeah, the only option you have is to use a ruler because I don't have any other information for you. So what we first have to know is the area of the square that would make that line, that would be a part of that line, that would be one side of that line. So now we've got this square that has that line length as one side of the square. If we remember what we did before when we were finding the square roots, the square root will give us square root gives us the side length of a square if we know the area, and that's the big if. Area of that square. So we do have to know the area of this square. Once again, you need more information. If all I give you is a line in a box, you're out of luck. But if I tell you what the area is of this square, with that line being the side length, then you can give me the length of that line. So let's just say that in this particular example, the area of this square is 36, and let's make it really big, miles. So it's 36 square miles, this area of this square. That's a big, big square. Clearly, we could not use a ruler to try to find one of the lengths of this side, so that's just not going to be feasible. So we're going to have to do this on a piece of paper and use this method in order to figure out how long is one of these lengths of this side here. So what do? We use the square root, and it says up here, the square root gives us the side length of a square if we know the area of that square. Well, that's great. We know the area. We want to know the side length. We want to know what x is, so I'm going to go ahead and put x in here because we don't know what that is. And so we'll set up our equation. X equals our side length will equal the area when we take the square root. And there's our square root symbol again. So the square root of the area is 36 of this square, will give us the side length of that square. Square root. What does that mean again? What is the square root? Oh, right. It's a number times itself. A number times itself that will equal the number underneath the square root. In this case, 6 times 6 equals 36. And so our side length will become 6 in this particular example. Now this is really handy, and it's going to come even more handy as we keep progressing through this unit that we're working on right now. But this is the gist of what I want you to understand. I want you to get the fact that if I give you the area of a square, you can find the side length of that square by taking the square root of the area. Now this one was nice because it was a perfect square. Remember, your homework for Wednesday night is going to be to memorize, if you have not already memorized all these, your perfect squares. So 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, all the way up to 12 times 12. So I know some of you have got that for sure and others don't, so this is your homework. Make sure you've got it memorized. Make sure you can work with it and use it confidently. That way when you see 36 here, you're like, oh, I know, of course, right off the bat, that 6 is going to be the square root of 36, because I know 6 times 6 is 36. Now, what do you do if you don't have a nice perfect square? Oh boy, so here's my line. I'm going to make it easier on myself this time and just draw a straight line here. And we want to have this square. Oops. And we want to find, we have to know the area. In order to find that side length, we have to know the area of that line. And I'm just making this a little easier on myself. Rotate that down. I can do it. I can do it. There we go. And we'll put this over in place. Need to make it. Here, I'll do it down here so that way it's a little easier. There we go. Now, what if I told you that the area of this square is not a perfect square, but is, oh, I'll just pick a random number, 18. And we'll use our old centimeters squared. So this is a smaller one. We could measure it if we had a ruler, but there's no ruler to scale on this. This is clearly not going to be 18 centimeters as it is drawn right now. This is not to scale. And so how do we do this? How do we find out 18 square centimeters? If you know your perfect squares, you know that 18 is not one of them. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Well, that's pretty darn close to that, but then 5 times 5 goes up to 25, so that's not 18 square centimeters. So we have to use a slightly different technique in order to get this, or really it's actually just kind of what I call finding the easy way out, which in algebra, you know, we're all about finding the easy way out. And so what I'm going to tell you to do on this is you have two options. There's two options. Option 1 is to write the side length as a square root. Right? Side length as a square root. And I promise I'll keep working on my handwriting with this tablet. It's a little weird. As a square root. So for this example, that would be the square root of 18. And we just leave it like that. That's one option, is just to say that the length of this line is the square root of 18. And that is the most accurate answer you can give, because the square root of 18 is an irrational number. It is a number that has a decimal that goes on forever and never has any repeating sequence to it. And so this is really the best way to write the answer, square root of 18. Well, okay, there's one better way, but we'll get to that one a little later. So option 2 for now. Option 2 for now is to give an estimate of the length. And what do I mean by an estimate? Well, we can't get an exact number. It's not like the square root of 36, which is exactly 6. Square root of 18 is somewhere between two whole numbers. So I know that the square root of 16 is 4, because 4 times 4 is 16. And I know that the square root of 25 is 5, because 5 times 5 is 25. 18 is between those two numbers. It's between 16 and it's between 25. And so we have to estimate that the value is going to be somewhere between 4 and 5, somewhere between those two. We could use a calculator for this. It's true. But for now, I want you to not use a calculator and just get a good estimate of what the answer might be. So if you're going to say somewhere between 4 and 5, well, you can give a lot of answers for that. You could say 4.5, 4.2, 4.7. But if you think about it a little bit, we have 16, and that's the square root of 4, and we have 25, and that's the square root of, or sorry, that's 5. The square root of 25 is 5. So 18 is closer to 16, and so I'm going to put it at somewhere around 4.2. Now, again, I have not checked this on the calculator, so I don't know how accurate I really am, but I know it's going to be on the small side of 2, and so I'm going to say 4.2 centimeters is approximately the length of this line. Of course, I could get better if I used a calculator, spend a little more time thinking about it, but 4.2 is a very good estimate of what the length of this line would be. So that's the part that I want you to do. And so for the rest of your homework tonight, you are going to be writing out some questions off to the sides here, just like we did last night. And you're going to write some questions that will relate to the work that we did over here. So again, just come up with another question that has the same square side lengths or has a different area for the inside. Make the first one a perfect square. So you can choose 36 or 49 or 64 or 4, any of those perfect squares. The second one, I want you to pick a question over here that is not a perfect square. So it cannot be 25 or 16 or 9 or any of those perfect squares. That way you have to estimate the answer or leave it as a square root. Either one will be fine with me. Okay, well that's it. But before I go, I had a request from Kurt that I include a joke on every one of these little videos. And so here is your joke for this homework. What happened to the plant in math class? Give up. It grew square roots. Oh man, these are bad jokes. But I hope you enjoy them anyways, and I will see you in class.